All right, week 15, set 2, SWYK number 1. So in question number 1 here, we're dealing with the following. Equation is given. List all the possible rational roots. Okay, so we take all the factors of the constant, which there aren't a whole lot, right? Divided by all the factors of the leading coefficient. Not a whole lot. Overall, you get 1, -1, 2, and -2. So that's it. They want you to list them all out, separated by a comma. Use synthetic division to test the possible rational roots. Now, when I looked at these numbers right here, 1, 3, 3, 3, 2, I thought to myself, the only way I'm going to end up with a 0 at the end is some of those are negative. You know, when we do the multiply and add thing, we've got to have some negatives in there. So that's why I chose to start with -1. And it worked, right? I got -1. I went through the process. I multiplied and added and multiplied and added. And I ended up with a remainder of 0. So what I was looking at was this thing right here. All right. Now, the truth of the matter is that's x cubed, right? We started with a quartic. This was a quartic to begin with. And so after we do the synthetic division once, that means we must be down to a cubic x, that's 2x squared plus 1x plus 2. And so I thought to myself, there's got to be another 0. And out of my possible rational zeros, I chose -2 to try again. And sure enough, what I noticed when I did notice how I just kept going. I didn't go back to the original quartic. I kept going with the cubic. Notice how I carried down the cubic and multiplied and added and all that good stuff. What I ended up with was a quadratic, right? If my remainders over here, my constants here, my linear terms here, my squared terms here. So that would be x squared plus 1. X squared plus 1. Well, when does that equal 0? Well, that's when you set this equal to 0, or I'm sorry, when you start solving. Now, it's a quadratic. Do I need the quadratic formula? No, not in this case. There's no linear factor, so I can simply subtract 1 to the other side and take a square root. But when you take the square root, remember you got to have the plus and the minus, and the square root of -1, that's I. That's not a real number. That's right, folks. We have two real numbers, which were -1 and -2. And if you look at the graph of this on Desmos.com or a graphing calculator, you'll see that this quartic only hits the x-axis 2 times, which means that the other two solutions must be, and neither of them bounce off the axis, so they can't have an even multiplicity. So that must mean there are complex solutions. And as you can tell, plus and minus I, they are conjugates of each other, which is a point that's brought up in the next problem. Secondly, find an nth degree polynomial with real coefficients satisfying the given conditions if you are using a graphing calculator or graphing utility. Sounds like it came from Batman's belt. Graphing calculator or Desmos. Use it to graph the function and verify the real zeros and the given function value. Okay. Now, why would I need to graph? Oh, they just want me to check and see. I don't think I need to do that in this case. I'll show you why. So they tell me that the degree here has to be a third degree polynomial, right? Right up here, they're telling me that my degree has to be a third degree polynomial. Then they tell me some more helpful hints. They tell me that 3 is a solution. They also tell me that 4i is a solution. Okay, now remember, there's a theorem that says that complex solutions come in conjugate pairs. Complex solutions come in conjugate pairs. Okay, what's a conjugate? Just as a reminder, something 4i could also be written as 0 plus 4i. Real portion being 0. Obviously, 4 is the imaginary portion. The conjugate of that is 0 minus 4i. In other words, the real portion stays the same and the imaginary portion changes. If you wanted to see that a different way, a plus bi, a minus bi. They're not opposites, folks. They are conjugates. Now, I do understand that 4i and negative 4i look like opposites also. True. Sorry. Now, my factors can always be written. Remember, every factor in the universe can always be rewritten x minus a number. X minus this, x minus that. X minus a negative number looks like x plus, but the reality is it's x minus. So you can see that I wrote out x minus 3 from the 3, x minus 4i from the 4i, x plus 4i from the negative 4i. Now, I want to multiply those things together. And so you can see that I like my box. You do not have to use a box if you don't want to. You can start drawing arrows, like first outsides, insides, last, that kind of thing. I just do the box and then I match things up. So x times x is x squared. And then x times 4i is 4xi. And then x times negative 4i, negative 4xi. And then lastly, when I take 4i and negative 4i and multiply them together, I get negative 16i squared. You see that I wrote that outside the box. That's because I want you to remember that, I squared is equal to negative 1. So that means that the bottom right corner of my box is positive 16. So I hope you see that those two things disappear, leaving me only x squared plus 16, which you'll see that I wrote below. Well, now I can multiply by x minus 3, all right? And now I'm just doing another box. Ratchet things up. When you multiply like bases, you add the exponents, so that's why I got my x cubed and so forth, and you can see what I wrote there, right? And so then I simplified it all from that box and wrote it here, x cubed minus 3x squared plus 16x minus 48. Now, they gave me one last detail on this particular problem, which I didn't know if it would make a difference, and it ended up not making a difference, but it could have. They said f of negative 1 equals negative 68, So they could have changed that to something like negative 34, and which would have made me alter this problem by adding a multiplier across the whole thing. But they didn't do that. So when I plugged in negative 1 to everything for every x value and went through the process of figuring it out, I did get negative 68. So that means I do not need to multiply anything. Like if it was negative 34, I would have realized, oh, they want me to cut it in half. So I would have multiplied everything in the red right here. I would have, everything in the red right there would be multiplied by 1/2. Or what if they said something like negative 134? Is that right? Negative 120, yeah. No, 136, negative 136. Then I would have multiplied the whole thing by 2. But they didn't say that. Question 3. Oops. Past our time, and we only got through question 2. Sorry. We'll add that to the next SWYK.